Hello everybody to a new episode of VASmalltalk C-API. After talking about an asynchronous call in the last episode, we will now take a further look into a variation of an asynchronous calls, which is called future call or static future calls. Before going into detail with future call, we will look again at the asynchronous calls we have mentioned in the last episode. An asynchronous call is done by the native execution thread, which spreads another thread and executes the external library call using an additional native execution thread. The main point in the simple asynchronous call is that the calling Smalltalk process is stopped until the external call finished and comes back to the Smalltalk image. Now, with the static future and the future call, the calling process is running without waiting for the result of the external library call. And somewhere in the future of this thread, the thread may query Smalltalk for the result of the external call. Therefore, future call or static future call. The difference between future call and static future call is very simple. For the future call, the system generates a new thread. For a static future call, the Smalltalk process creates a new thread and uses this several times. This is urgently needed for APIs which have thread-oriented data, and therefore you have to call the API always with the same thread. So the practical part of this episode, we want to call a function which is called long-term action, and you see we have a parameter of a double value, and here it returns a double value. Therefore we will have to look at how we can get the value from a future call. And within this function we have a delay of 4 seconds, and then we return the value, which is a square value of the parameter. This is the Smalltalk part of the example. We have defined the external function here. We prepare the parameter, and then we fork a background Smalltalk process to do the future call. The future call itself is done in this line, future call with. Then you get a future, and then we wait for the future. And as I mentioned in the introduction of this episode, the Smalltalk process continues to run, and therefore you have to poll the future if for the return result of the external function call. And therefore you call the future if it's ready. That means the external process has finished. But if it has finished, then it can get the return result by sending the method value to the future, and then we print the result here. Otherwise, we wait an additional 500 milliseconds for the value, and then we just print the parameter value. Now we will execute the function. We are waiting 4 seconds, and there it is. The function library caller has returned, and here's the value. The difference between the static future call and the future call are mostly syntactical sugar. We have the same example than we've seen before, but now we use a static future call. First, for the first time, we have to create the static future for by ourselves from the ACO resource manager, and then we do the platform call. Now we have 2 parameters. The first one is the future itself, and the second one is the second parameter here is the first parameter of the external function. We make the call. The rest is more or less the same, but at the end of this example we return the future to the resource manager perhaps for reusage this in your program. Well, the syntax and semantic, the syntax changes a little bit, but the semantic is the same, as you can see from this example. And after 4 seconds, the value changes because the external function call returns. That was that. To summarize, the first episode shows you the synchronous calls, the asynchronous calls, but perhaps the most interesting part is that the asynchronous calls, either the simple one or the future-based ones, are much heavier in CPU resources. Asynchronous call takes around 100 times more time to do the call itself than the simple synchronous call. But